Okay, good afternoon everyone. Thanks Sylvia for that great introduction. So I'll be sharing you the synthesis of the case studies that we've done so far using the wildlife tolerance model. So this model I developed for my PhD, and it basically hypothesizes the factors that determine tolerance to different wildlife species. And to date, we've applied it in 9 different countries with 12 different species. So these are the students from Imperial College in the UK that have applied the model. And I'd just like to acknowledge them with Dr. Andrew Knight, who is co-supervising them with me. And then these are the case studies that I've applied in South Africa and Namibia and Zambia. So altogether we have 23 case studies, and you'll see that some species have been applied in different countries as well. So I'll just go through the model now. So the model consists of 2 components, an outer model and an inner model. And in the outer model, experience is the first variable, and we operationalize that using exposure to a species, so how often someone has seen a species or signs of it in the last year, and then the types of meaningful experiences they've had with the species, so either they can be either positive or negative. Then we have benefits and costs. And these are divided into tangible, which refers to the monetary value, costs and benefits, and the intangible costs and benefits. So intangible costs refers to the psychological negative emotions associated to species, like worry and stress, and the intangible benefits refers to the cultural value or appreciation of watching a species. So the first hypothesis is that experiences with the species drive perceptions of costs and benefits. And then the second hypothesis is that perceptions of costs and benefits determine tolerance. Then in the inner model, we have 11 variables that are predicted to influence perceptions of costs and benefits. So for example, if we take empathy, the hypothesis is that the more empathy you have for a species, the more benefits you'll perceive, and then the more tolerance. And we also predict that these inner model variables can directly impact on tolerance. So we operationalize tolerance using 4 constructs. The first one is tolerance to killing a species. So this is a measured support for killing a species under 7 different scenarios in increasing severity. The second one is tolerance to population size, so would you support increase or decrease of the population. The third is tolerance to spatial proximity, so how many days a year are you willing to cope with having a species on your property or your land. And the last one is tolerance to monetary loss. So we use partial least square structural equation models to test the hypotheses of the model. And this is a diagram showing that we basically test relationships between the variables. And these single-headed arrows indicate the relationships, which with strong theoretical support indicate causal relationships. And then we use path coefficients to determine the strength of the relationship, which can be interpreted as beta values in normal regression analysis. So for this analysis, what I did is we simply list all the different options of paths between the variables. And for each case study, I just reported whether that path was found to be significant or not. And you can just calculate a percentage for each path of case studies that were significant or not. So this is another representation of that table, which just shows all the different paths, and then the solid lines indicate where more than 50% of cases were found to be significant for that path, and the dotted lines were where more than 50% of cases were found to be not significant. So there's quite a lot to interesting things going on here, but today I've just got time to share with you 5 key learnings from this analysis. So the first one is that 50% of variation in tolerance is explained by the model. So we measure the coefficient of variation, and that basically just explains how much all the variables in the model explain tolerance. So 50% is considered quite good for the behavioral sciences, because behavior, we know, is very difficult to explain. The second key learning is that monetary costs and benefits are mostly not significant. So tangible costs in 96% of cases are not significant, and benefits in 80% of cases. But what's important to note here is that we shouldn't conclude that money isn't important to individual people, because all this is saying is it's just not a linear correlation. So 2 people could experience the same amount of monetary damage, but they could have different tolerance levels, because money means different things for different people. The third key learning is that empathy and intangible benefits are mostly very significant. So for empathy, it's 82% of cases, and intangible benefits tolerance. So the more empathy and the more intangible benefits you perceive, the higher the tolerance. So an obvious question is, how then can we increase empathy and intangible benefits? And this is the utility of path modeling, is you can then look at which are the variables that impact benefit intangibles. So in this case, exposure and the meaningful events. And what we find here is that exposure and positive meaningful events are significant in about 50% of the cases. So the more exposure, the less intangible benefits, and the more positive experiences, the more intangible benefits. And then for negative meaningful events, it's significant in about 35% of cases. But the positive meaningful events, we find it's mostly for primates and ungulates, but not for carnivores and elephants. And for the negative meaningful experiences, it's mostly for carnivores and primates, but not for elephants and ungulates. So besides the wildlife tolerance model variables, other promising avenues to increase intangible benefits are through social learning programs with training in nonviolent communication and global sustainability challenges, which I've been applying in Namibia. And yeah, welcome anyone who wants to discuss those more with me later. The fourth key learning is that intangible costs are also important in about 50% of cases. But what we hypothesize is, in cases where you have lots of different damage-causing species, it's possible that maybe the cumulative damage from all the species could affect tolerance to the specific target species. So what we find is that does seem to be the case. In 70% of cases we find that, although we've only measured that in Zambia and Namibia. So this is potentially quite important finding, because it means that in high biodiverse areas where you have lots of different damage-causing species, we can't only focus on the charismatic species. So for example, where people experience lots of damage from bush pigs or porcupines, it could affect tolerance to like elephants or other charismatic species. And in general, many qualitative papers have highlighted the importance of intangible costs, but they're not often measured in quantitative surveys. So we need more case studies to look at that. And lastly, since we found that intangible costs and intangible benefits are important, we want to understand how exposure affects intangible costs and benefits. And we find that it mostly has a negative effect in around 50% of the cases. So more exposure leads to more perceptions of intangible costs and less perceptions of intangible benefits. But what we find is that baboons might be an outlier and have actually the opposite effect. So more exposure for baboons is actually a good thing, but we do need more case studies to see if that holds. So then to summarize, the wildlife tolerance model has quite a good explanatory power for the behavioral sciences, around 50%. And we find that a few paths are consistently significant across all these case studies with a medium effect size. And then there are a whole bunch of other paths which are significant in about 50% of cases. So we do need more case studies to try and unpack what are the contexts of where these other paths are important. And lastly, path modeling allows one to better understand the effect of one variable on the other, and it can help to inform management interventions. For example, we can reduce exposure by implementing mitigation measures or spatial planning for corridors. We can do education programs to reduce negative, meaningful experiences and increase positive meaningful experiences. And the social learning programs that have been applying in Namibia also look potentially useful to increase empathy and intangible benefits. So, I hope I've managed to convince you that the wildlife tolerance model is quite useful, and I invite you to join me in increasing the number of case studies.